Hello friends, today I am going to solve LeetCode problem number 382 linked list random node. I have also created another video solving the same problem using O of n time complexity but O of 1 space complexity. Now in this video I am going to solve this problem using O of 1 time complexity and using O of n space complexity. So let's see how we could solve this problem. Before that, let's see the problem statement. So we are given a singly linked list and we need to return a random node value from that linked list, and each node must have the same probability of being chosen. So now we are given a solution class and we need to implement these two functions. The first one is the solution function, which is the constructor, and the second one is a getRandom function. The constructor is passed a head argument and we need to initialize our object using that head. And in the getRandom function we need to choose a random node from the linked list and return the value of that node. So how we could solve this in constant time complexity but O of n space complexity. So let's look here. So initially what are we going to do is, since this is a linked list, we always start from the first, right? So let's suppose I want to reach a second node. I want the value of the second node. We cannot just use indexing just like in case of array that has the indexes 0, 1 and 2, and that would give me the value of this second node instantly in O of 1 time complexity. However, since this is a linked list, we start from node 0 and we keep on iterating until we reach the node at index 2, right? So this basically would take in the worst time O of n time complexity. And in case of array where we have the indexings, that would only be in O of 1 time complexity, right? Because we have the indexes and we can always access the value of the array at that index using the indices, right? So that is what we are going to do. We are actually going to convert our linked list into an array and then get the value of our value at a random index, and that would be our final answer. So what we need to do is we need to first of all create our array. So that is what we are going to do in our solutions function, and then in getRandom we are going to generate a random integer, a random index that would be in the length of this array. So that would be less than 3 and between 0. So how are we actually going to generate that random number? So in JavaScript we have a math.random function. We are going to use that math.random function to generate a random number. However, in JavaScript this math.random function only generates a random number between 0 and 1. So how are we going to get a value at value that would generate a value between 0 and 2? So basically what we need to do is we just need to multiply this whole thing by the length of our array. So that would give us the random number that we need to between 0 and the length of this array. So how is actually that working? So let's just suppose the random number generated is 0.3, and once we multiply a random number with any other number, the resulting number will always be random. So let's just multiply it with the length of this array, which is equals to 3, and the result would be equals to 0.9. So in this case we are going to only choose use the floor value of this integer, because we know 0.9 index doesn't exist, right? So we are going to use the floor value that would be equals to 0. So at index 0 we have the value 1 and we return that value. What about we have a random number that is 0.7? If we multiply it by the length of the array we get the value 2.1, right? And since we are using the floor value, we get the value at index 2, and that's equals to 3. What about we multiply it by 1? So if we multiply it by 1, actually it doesn't return a value 1. The random will never return a value 1. It will only return a value 0 to 1 exclusive. So the max value we could get is 0.9 times 3. So that will return us a value equals to 2.7. So the floor value will be equals to 2, and that will be our last element. Actually, since it's from the value from 0 to 1, the last value could be 0.99999. that would still be less than 3. So our floor value will always be equals to 2 for that case, and we will never exceed the length of, we will never go out of bound of this array. So that is what we are going to do. We are going to use the random function to generate a random number and then multiply it by the length, and that would give us the random number, and we are going to use that random number to get the value at that index. So let's create our solution. So first of all, we are going to create an array from the linked list. So let that array be our new array. Now we will iterate over each of the value in our head and add those to our array. Now once we have added this to our array, we are done with our constructor function. Now we need to get our random value. So let random value be equals to, so we are going to use the floor value, and then we are also going to use the random function from JavaScript and multiply it by the length of the array. So this dot array dot length gives us the length, and this would return us a random value. Now we are going to iterate over that random value until and unless we reach that index. So starting from I equals to 0, I is less than random value, actually less than or equals to random value I plus plus, and we actually do not need this. So now that we have a random value, we are going to return the value at that index. So we are going to return this that array at rand value index. Now let's try to run our code and check if everything works fine. Awesome, let's submit it. Great. So as I already told, the space complexity for this solution is of the get random solution is O of 1 time complexity, and space complexity is also O of 1. However, the get random function, since it uses an array which takes an extra length, so that is O of n space complexity, but the time complexity is reduced to O of 1. And this solution, this is also O of n space, but time complexity is also O of n. However, since the solution will only be called at once in the beginning, and the get random function will be the function that will be called most of the time, as you could see in this example that we are only calling the solution function 1 and the get random most of the time, right? So that is why we are solving the problem in O of 1 space complexity, which should give us the most optimal solution.